Hi, everybody. Welcome to the fifth lesson of OffChain Code, Beginner Web3. Today, we're going to be talking about scope in JavaScript, as well as smart contract verification. So a little bit about myself. I normally live in Guangzhou, but actually today I'm here live in Kunming in Yunnan province. I've been doing software development for quite a while now. Previously have worked in IBM and a number of other cryptocurrency exchanges, and I'm now working at an international bank, nothing related to crypto, but still very interested in this area and always will be. I love to travel, and if you guys want to connect up with me anytime during the class or after, feel free to reach out to me on any of the means I've provided down there. We're not going to be going into too much depth in this course, so this is not going to make you a full-time programmer, but it's going to give you a basic understanding. We picked JavaScript mainly because it is the main programming language that is used for web development, and we're trying to show you how to interact with blockchains. You're not going to get too deep into Solidity coding in this course, but we're going to show some of the basics of how smart contracts are developed and what you can do with them. So this is the fifth lesson. If you've not been through the other lessons, hopefully you'll be able to keep up. We're actually going to start with something that you can take away regardless if you've seen the other classes, and that's smart contract verification. And just curious, did anybody hear about Squid Game? Not the Netflix series, but the scam token that was launched on Binance Smart Chain. Anybody in the room hear about Squid Game? All right, we got some hands up in the room. This is critical stuff. Look, even if you're not going to be a smart contract developer, the things I'm about to teach you here are actually going to be very relevant, even if you're just doing cryptocurrency investing or playing around with any dApp, smart contract whatsoever. And we're going to take a look at Squid Game because it just happened this week. Mainstream media news is putting all this out about, yet another cryptocurrency scam. Oh, nobody could possibly avoid this. Yeah, you can. Here's how. So pay attention. This stuff means something, and it actually is not that hard to learn. Although it is technical, it's not that bad. We're going to go through it. So smart contract verification, we often use a tool called Etherscan. Now, Etherscan itself is not the blockchain. All it is giving you a view as to what the blockchain has in it. We've used that in the past exercises to take a look at smart contracts. We're going to today look about verification. When a smart contract goes onto the blockchain, it goes in as code, zeros and ones, in fact, meaning that if you're looking at a smart contract, you're probably not going to find it all that interesting unless you can decompile it. That means we need to be able to take those zeros and ones and turn it back into the source code that it was originally written in. What we normally think of as zeros and ones are actually called object code. Again, we're going to stay at a beginner level. We're not going to go into what is object code or assembly language. Go in ahead, though, if you're interested in this stuff, Google it. This is how any computer runs. It needs to have zeros and ones. We're not going to talk about how it works, but it matters. What a best practice is, though, is when a smart contract developer publishes code, they really ought to publish their source code with it. Now, they don't have to. In fact, if you really wanted to, you could look at the zeros and ones and figure out exactly what they're doing. Problem is, most of us don't read zeros and ones. Computers do. And if you don't publish the source code, it usually just means that you're either being careless or you're being nefarious, doing something really, really bad. Either of those are a huge red flag. As we saw this week with Squid. The Squid Game was a token that was put out by a scam project. As best as we can tell, it's a scam project. It has nothing to do with the Netflix series, although it's a really cool show and highly recommend it. But they were trying to say, oh, look at this really great gaming token. We're going to do exactly like the game on the Netflix series. You're going to be able to play and you're going to make lots of money. Sure. Do, ha, ha, ha. Nope, it's a scam. So we look at Squid Game, and what you can see is they have a similar to Etherscan, bscscan.com. So every smart chain, every blockchain out there tends to have some sort of variant of Etherscan. Etherscan is probably the biggest one, and of course, there was others that came before it, but they tend to have something very similar to this, which is called a blockchain explorer. This is the way to view a smart contract, meaning that if you're interacting with any sort of NFT or any sort of ERC20 compatible token, chances are you'll be able to go find the contract address And whenever you're dealing on an exchange, you should go look up what smart contract am I dealing with. They'll publish this information. This is really what's powering that token. You can then come on in, search for it, and then you're going to find the actual smart contract that is being used for that. And in fact, they've already labeled it here as a heist, meaning it's a scam. So be careful. But we're going to take a look at it. What you can do with a tool like BSC scan or Etherscan is you can see who's interacted with it. And this is good. It means that one thing that you might want to look at is, did anybody else deal with it? If you're the first person and you're not the developer, or you've only seen a handful of other people, either you're really certain you're dealing with something that you trust, or it's a big red flag. It means that, well, if you're one of the very few people dealing with it, probably it's a scam. Maybe nobody else has dealt with it and you accidentally copied and pasted the wrong token. Red flag. Look for these things. How many holders are there? This is kind of interesting. 119,000 addresses, potentially people, interacted with this scam token. Kind of sad. So don't just rely on numbers alone, but it's an indicator. If you're one of the few, that's a scam, probably, unless you know that smart contract. And you can also see where the DEX trading is happening. So people might be trading through many different exchanges. This allows you to see some more information. The thing that we wanted to focus on in this particular class was the smart contract. Missing. So when you're dealing with a new token, and for whatever reason, they decided to just not publish their smart contract here, it's going to show up like this. Sorry, there are no available contract ABI methods to read. ABI, what is that? So going back to our PowerPoint, application binary interface. So normally, when you publish a smart contract, again, it's publishing in the zeros and ones. Optionally, the developer can go and publish their source code by taking the ABI, the application binary interface, and posting it against the smart contract. What this does is it marries up your source code that you have and something that most developers can read with the binary interface, which most developers probably, or even regular humans, wouldn't want to deal with. It allows then some degree of certainty to then say, reasonably, you could be able to figure out what this thing's doing. If they don't publish it, it's a major red flag. I will personally never touch any smart contract that doesn't fully publish their source code. Why? It's not because I believe in open source as being better than closed source. It's just that there's just no need to be that lazy. It's open source by nature. I could go and read the zeros and ones if I really wanted to, but if you're trying to hide something from me, don't trust it. It's probably bad. And, another way you can look at this is to look at the comments. If, don't always believe everybody else, do your own research, but if lots and lots of people are putting a lot of fear, uncertainty, and doubt, FUD, on into the comment section, you're probably going to need to trust them. Go look into it. So this is a good way to go and do some basic research. So what does it look like when you have a legitimate contract? Well, last lesson, we published an ERC 721, an NFT. And after class, I went ahead and did what good developers do, and that's publish the ABI along with my source code to then show you. What you can now see on my ERC 721 is when I go to the contract section, well, yeah, nobody else has dealt with it, so that's a red flag. It's only me, so nobody else did anything. That's still a red flag, but at least my source code is here. In fact, Etherscan, which I'm running on Coven, shows me all the nice methods laid out. You don't even have to be a developer to read this. This now shows me that there are some methods here and they're public. If you want to, though, and you are a developer, you can click on code. This will show you exactly the source code in question that's powering this smart contract. Now, I'm not saying source code alone means it's legitimate, but it's a heck of a lot more than nothing at all. So whenever you're doing your own research on a new project that you're potentially going to invest in or interact with, make sure you look for this type of stuff. If you can't find the source code in question, don't deal with it. And if you want, you can use tools like Etherscan to then actually interact natively with this smart contract. You don't even have to use the dApp. This is more advanced, but it's pretty cool. This is actually literally a MetaMask or other Web3 plugins are interacting with the smart contract. Make sense? If you want, again, you could literally go mint a new NFT by calling this and putting in your address. Pretty cool stuff. That's literally how these blockchain applications are working. So I hope that gives you some background now. Like, don't be one of the 120,000 people interacting with Squid. I am not here to advertise those scam tokens. What I'm here to show you is some basic knowledge on how you can avoid those sort of scams. Okay. We're not going to get in today as to actually how to publish the ABI information, but if people in the class want to learn how we did that or how I went through it, feel free to ping me offline in Discord or WeChat, and I can show you some of the steps that you can take on how to publish from Remix even the ABI and get it verified on the blockchain. Today, we're going to go into something more technical, which is scope. And it's not the scope that I posted here, and it's not the scope on your rifle as some people were putting into the Discord. This is scope as in what is going to be how a compiler interprets a variable. Scope is very important for many programming languages. This is not just a JavaScript concept. If you go into just about any programming language, you're going to find likely some element of scope. And this matters a lot for new developers because it's an awfully very confusing area, especially when we get into functions, and especially even more when you start dealing with many, many different pieces of source code. You'll often start to define a variable. So maybe you call the variable count. You're oftentimes counting something and you forgot where you declared that variable. And then suddenly you use that variable again somewhere else and it's not doing what you expect it to do. This is a programmer's worst nightmare in debugging. You then have to start figuring out where in the stack trace this variable is now being manipulated in a way that you didn't expect it. It's really a pain. A good way to avoid this pain is don't have it. So learn what scope is and try to limit where you're putting your variables. By default, when we were doing our past lessons, we were just declaring variables left and right. We weren't concerned at all about scope. Well, those days are now ending. We want to think about how we're defining our variables, and we want to limit our scope as often as we possibly can. We want to narrow the scope down so we don't accidentally introduce global variables. We're going to get into that today as to how to do that and why it matters. I'll also put out, try to make good variable names. You will make mistakes. You will accidentally declare things global when you didn't mean to. And if you use better variable names, you'll oftentimes avoid catastrophe. So in the past, you may call, count as a variable. That is a terrible variable. I don't know what you're counting. I don't know why you're counting. Don't know when you're going to use it again. Maybe a better variable would be like counting stars, count stars. It clearly indicates that you're counting, so it's going to be likely an integer. And it tells me what you're counting, stars, which means that I shouldn't expect to see, actual stars being referenced in this variable. I should see some sort of integer and that you're counting. So try when making good programs to use good variables. That variables are cheap. Define them very explicitly and very clearly so that somebody like yourself a few years later knows what you're talking about. Okay, so we're going to come on over now into Code Academy. At this point, you should be on lesson 5, which is scope. And they're going to get into the technical definition here of what is scope. Scope defines where variables can be accessed or referenced. That's an interesting word. We'll talk about that later. While some variables can be accessed from anywhere within a program, other variables may only be available in a specific context. So in this case, they're saying the night sky from your window, everyone who lives on the planet Earth is in the global context of the stars. The stars are accessible globally. Everybody can see the stars. Meanwhile, if you live in a city, you may see the city skyline or the river. The skyline and the river are only accessible locally to your city. But you can see that the stars are available globally. I actually kind of take offense to that because if you look at the night sky from different places in the world, it's actually going to look different. But needless to say, the stars are universally global. They are not, restricted in any way from where you are. They are always going to be there. But if you're in a city, you will only see that city view if you're in that city. So this is a kind of an analogy for what is scope. Let's go through some exercises because this is a pretty confusing subject. Blocks and scope. So before we can talk about scope, we got to talk about what are blocks. Blocks are ways of logically laying out your code, and we've seen them already before. In fact, when we were talking last week about functions, functions used a block. These curly brackets are allowing us to see that it's a block of code. So blocks help us group one or more statements together and serve as an important structural marker in our code. Let's go through an example. So right now, I've got a file open, main.js, and it's saying at the top of main.js, declare a const variable. We did variables before, so const. And it's saying set the variable to be city. Set it equal, so I'm going to use my declaration of equal. And then we're setting it equal to a string, New York City. The variable will exist outside of the block, meaning that because there is no block, you see no curly braces in this, this is now a global variable, something that is accessible everywhere. Run it, and you should get the checkbox. Now below, we're going to make a city variable. We're going to write a function. We're going to make a function called log city skyline. So this is the hard part. If you remember last lesson, we defined functions in many different ways. There are multiple ways to declare functions in JavaScript. So it's up to you how you want to do it. One way, as we learned, was to do log city skyline. And we could give it no parameters, because at this point, they're not telling us any parameters. And with ES6, we can now declare it simply by that. That is one way of declaring the function. If you forgot the other ways of declaring a function, now is a good time to go back to lesson 4 and review functions. But this was one way of declaring a function. Inside of the function body of log city skyline, we need to write another variable using let. And we're going to name it skyscraper. We're going to set it equal to the Empire State Building. So function body means that we're now going to be going into the block. As we said right here, our block is empty. They said define a function. They didn't say what to put in it. Now they're telling us they want something in it. We need to expand this block and put in it a new variable. Let skyscraper equal Empire, if I can spell it right, State Building. Okay. Inside the function, include a return statement like this. In fact, the easiest way to do that is copy and paste. Remember, functions optionally can return something, and in this case, they're having us return a concatenation of multiple strings. We're combining the stars over the variable skyscraper, concatenated with a global variable. Wait, we don't have city defined within this function. Will it work? Let's see. We click run, and what should happen? Anybody in the room? Nothing. We defined the function, we didn't call the function. So nothing happens yet, but we did pass this lesson. So now we're on to the fifth part. Let's now call the function. Beneath log city skyline function, we need to use console.log to log the value of log city skyline. So now they want us to call this function. Console.log, this prints something out to our console, and they want us to call the log city skyline function. We can just copy and paste that on in, and we can now run it. Now it's going to evaluate it. Anybody in the room want to guess what it's going to say? We got a developer in the room. Now he's put on the spot.
I'm gonna say the stars over the building.
Correct. The stars over at New York City in New York City, and that's going to be printed out. As you can see, global variables, even if they're not defined within this block, are accessible within this block of code. Cool. Now, we can follow the lessons, but feel free when you're doing these lessons to kind of ask yourself, well, what happens if I use something that wasn't global? So we can then say, let skyscraper is defined inside this block of code. Now I'm getting ahead of ourselves, but it's good to kind of ask these questions as you go through these exercises to just play with it. There's no harm in breaking stuff in here. It doesn't matter. So try breaking it. What I like to sometimes do is just say, I'm interested in what is skyscraper. So I'll make a string called skyscraper equals, that's a string. I'll just use a plus sign. And then I'll say, I want to know what the skyscraper variable is. Now, what's interesting is I'm just calling skyscraper variable. Looks like a valid variable. It's kind of printed here. Let's run it. What does it do? So we still get the original thing printed out because it got to line 8 and evaluated it, and it prints it out, and then it blows up on line 9, which kind of makes sense. Skyscraper equals, well, that looks fine, and the plus sign looks fine. I'm adding 2 strings together, but skyscraper is not accessible. Why? Because it's scoped inside this block. Variables that are defined inside of a block of code are not going to be accessible globally. When I call this on line 9, I'm now back in the global sense. I'm not inside the same function. I cannot use that variable. It's now giving me an error saying reference error, meaning, remember I said, what is a reference? Well, this is a reference. I'm referencing the variable. If you've not put it in a scope where it's accessible, you can't reference it. Therefore, it's going to error out. It's saying skyscraper is not defined at object.anonymous, blah, 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 blah. Kind of hard to understand, but it's just saying this, the skyscraper variable is not accessible. If you wanted to get to it, you'd have to call it from where it's accessible. You could move skyscraper directly on into this function, but as you can see, console, the stars over there, yeah, well, okay, let's get on into the lessons now. Global scope. Scope is the context in which our variables are declared. So we went through this last exercise and we said that first variable that we were defining, that was in global. Let's talk about some of these global scope variables. So at the top of main.js, write 3 global variables. Oh, sorry, I've already done this exercise. Let me reset it. One moment. There we go. Nobody saw that. All right, so we need to define 3 global variables. So the variables, they didn't say what type of variables they're going to be. So we can use const, we could use let, I'll use let. Let satellite and set it equal to the moon. The next one they want to be the galaxy. Let galaxy equal the Milky Way. And finally, let stars equal North Star. Run. Cool. We now have 3 global variables because they've not been put in any block of code. Below the variables created in the previous step, write a function called call my night sky. And inside this function, include a return statement like that. Again, many ways to define functions, but the one that we kind of prefer, const call my night sky is going to be equal to a function which has no parameters. I then put a block of code, and in the block of code, I'm copying and pasting what they want me to return. Cool. It does nothing though, because although I've defined the function, I've not called the function. So beneath the call my night sky function, we need to now call it. So they want us to console.log, and we're now going to call that function. Remember, to call a function, you have to, even if it includes no parameters, make sure you put the 2 parentheses next to it with no parameters. Run it. Night sky, the moon, North Star, and the Milky Way. As you can see, it is accessing all those global variables. Let's keep going. Now we're going to get into, okay, what are these block scoped variables that we're supposed to be using, because we're not supposed to apparently be doing everything via global variables like we've been saying. So the block scope works like this. Here's an example of log sky color. It's going to print out what is the color of the sky. And we can see that rather than making the sky always blue, which probably would be a good idea, but maybe we're on a different planet. So who knows? In any case, this sky color is now always going to be blue, but only within the scope of this function, not globally. When we call it, we expect to get blue, but if you try to print out the word color, you're going to get that reference error. So let's try a different idea. They're giving in main.js, define a function, log visible light waves. Interesting. Const log visible white waves equals, again, the function hasn't been given any definition. So we'll use the notation here to just create a blank function. Run. Within the log visible light waves function, using the const, create a variable light waves and set it equal to moonlight. So we're going to use const light waves, set it equal to moonlight. Run. Within the log visible light waves function, beneath the light waves variable, add a console.log statement that will log the value of light waves variable when the function runs. Console.log. Now we can just, light waves. Now they're saying to call it. So we can do log visible light waves. We can certainly just call it like that. Moonlight. Cool. Now, beneath this function call, log the value of light waves to the console from outside the function. You'll notice that you're going to get the reference error. So just like we did before, console.log, if we try to print out light waves variable, reference error. Again, you can't use variables that are defined within the scope. Make sense so far? Okay. Scope pollution. So this gets back to the best practices and bad practices. You really don't want to be defining variables all over the place. Otherwise, you could easily make a mistake where you thought you were using a variable that was clean, but it's actually been manipulated. So here's an example. Let num equals 50. Again, right off the bat, I don't like it because it's using the word num, meaning number. And we didn't really say what this number is going to be doing. So it's ripe for making a mistake later in your code where you might accidentally use a num again and, well, you didn't expect it to change. They then declare a function log num. So they say num equals 100. So now my 50 just changed to 100. When we console.log num, what should we get? Well, you're going to get 100 because you modified it with this function call. Even though you modified it in this particular local scope of this block, it modifies the global variable. So imagine you're writing some code and you start to copy your code, num equals 50, then hundreds or thousands of lines later, you declare, this constant function, which modifies it in a way that you don't expect. Then hundreds or thousands of lines later, you're going to use the num and you're like, yeah, I can see on line 1, it says num equals 50. No, something modified it in between. That's the danger of using global variables, and scope pollution is what you want to try to avoid. Okay, let's try an example. Let's see what happens if we create a variable that overrides a global variable. Inside the call my night sky function, one of the very first lines of the function body assign the variable stars to Sirius, such as stars equals Sirius. Okay, so we'll do it. We can see up here on line 3, stars equals North Star, but now we're polluting it, and on line 6, we're overriding it to be stars equals Sirius. Run. The moon, Sirius, and the Milky Way. Outside the function, under the current console.log statement, add another console.log statement to the log stars to the console. Console log. We can then say stars. I like to do this just so it's clear what we're printing out. Stars equals plus stars. It's very easy to make these programming mistakes. So just be careful when you're declaring global variables that you don't accidentally modify them. Okay. So how do we do it correctly? Practice good scoping. Here's a better way of doing it. If we declare a function, we should put our variables that are necessary for the function inside the function. That way it's more modular. If I go back later, modular means that I'm going to go back and say, oh, I want to modify this function. I don't now need to go and modify a bunch of global variables that may be used elsewhere. I just have to modify that one function. We try to think of things in programming as objects. And you don't want to have objects that are kind of all over the place like spaghetti. Spaghetti is really hard to tease apart. But if you have, a single meatball, you can easily pull that on out and change it and make it exactly what you want. But if it's all over the place, you're going to have a really, really hard time modifying your code. So in this case, let me reset. Let's go ahead and try an example. Inside the function body of log visible light waves, beneath the region, which is set to the Arctic, and before the provided console.log, create an if statement that checks if the region is the Arctic. So we can put in here, or they have the comment add if statement here, if, and they want us to then say region. And now how do we check if it's equal? Anybody remember? This is JavaScript. How do you check if two things are equal? Anybody in the room remember or no? 3 equal signs. Very good. Yes. Don't be confused by JavaScript. I have no idea why they do 3 instead of 2. Most other normal languages just settle on 2, but JavaScript's fun. 3, sure. Okay. So if region equals the Arctic, what do they want us to do? Create an if statement that checks it. I guess they want us to actually then only print it out on that. Sure, but nothing there. I think that's all they want us to do. Yes, okay, do nothing. So we have an if statement that does nothing. It checked and moved on. Inside the if block, define a new let variable light waves and set it equal to the northern lights. Okay, so if we create a new variable, let light waves. Now, we already had light waves defined up here, but they want us to redefine it. Let's do it. Let light waves equal northern lights. Run. Perfectly valid. You can redefine the variable name. Beneath the variable in the if block, use console.log to log if the value of the block inside the variable inside of the if block. Okay, so inside this if block, again, remember, if conditional statements, just like functions, this is another block. It's another type of scope. Inside here, we can do a console.log light waves. So what is it going to print out before I run it? Anybody want to take a guess what it's going to do? We have light waves equals moonlight. Region equals the Arctic. So it is the Arctic. Line 5, region equals the Arctic. Well, yeah, we're still in the Arctic because that's what was last said here. And we're now setting it equal to the northern lights. But wait, region equals the Arctic. What's it going to print out here? Light waves. Northern lights. All right, let's run it. The northern lights prints out. Cool. And then wait, what? Huh? Then it goes back to moonlight. So what you're seeing from here is scope matters, and it's local to that scope. And in fact, once you leave that scope, it's as if it never happened. Huh? We changed light waves to northern scope. And then as soon as that scope ended, it reverts back to moonlight. Okay. So these are interesting scope dilemmas. Yes, you can modify variables inside these scopes, but if you declare it in another scope, that other scope will take precedence and it'll then revert back. So if you've not defined it globally, you're not modifying the global, you're only modifying that local one. So this is where heads will start to spin a while. I don't think you're going to get it on the first pass. If this is the first time you're seeing scope, play with it, practice it, try it out. Don't just use this one example. You're probably going to have to do it a few times. This is a really confusing subject for every new programmer that comes about. So don't feel too confused. It's normal. But it does take some practice to figure out what scope's going on. As we showed before, I like to play even more. What if light waves equals 1, 2, 3? It can be anything. What's it going to do? Stays the same. So even though we had scope of global light waves, 1, 2, 3, once we get on into this local scope, it's winning. That is now the answer. Global doesn't matter anymore. If we come down here, console.log, anyone want to take a guess? What is light waves going to equal? Type. Anybody want to guess? It's hard. So we have a couple different possibilities, right? It could be the northern lights. It could be moonlight. It could be 1, 2, 3. You got 1 out of 3 chance. It's not that hard. Let's just run it. Light waves equals 1, 2, 3. Who would have guessed? Again, the scope was local. Because we defined this globally, and because this is running globally, it didn't matter that we modified it in this local sense. That variable is going to, even though we changed it in here, it's still globally set. This really can make a lot of head spin when you're first getting new to programming. You would have almost thought, like, didn't we show a previous example of like changing it? What happens if we don't define it again? What if we light waves equals moonlight, but we're reusing the global one? What happens now? What? So if you declare the variable globally and then you modify, not redeclare it, but modify the variable, it's going to modify the variable globally, even when you get back out to the global sense. Again, if this is your first time programming, which most of you are, you need to play with this. Just toy with it. Try changing some of these things around until you get it, because this is a confusing subject that doesn't first sit in until you start understanding. Once you've defined something globally, it's now set globally. If you modify it in the subcategory of a local setting, it will modify the global permanently, forever. But if you redeclare it new, even with the same name, you've effectively made a new variable. You've not modified 1, 2, 3. You've just made a new light waves that only exists locally, and it will continue to exist here. Once you get back out to global, that local gone. It doesn't exist anymore, and it'll now revert back to what it did exist, the 1, 2, 3. Okay, this isn't in the exercises here. Again, the only way to learn, keep trying it, try it, lots and lots and lots of times. So we have lots of extra time here. Review the scope. I don't think they go into enough detail in this particular area of Code Academy. As you can see, when we were playing around, sometimes I can make a twist to these exercises and you'll find that it doesn't do what you might expect it to do. Take some extra time on this one because at least for me, when I was first learning programming, this was one of the hardest things. It ends up confounding you greatly once you have multiple files where things start playing around with the variable scope even more. So take some time. I also encourage you, go and take a look at some of these smart contracts that you use already. If you own some cryptocurrency, don't just settle at owning it within the exchange. Go on out to the Etherscan and poke around. Look at the smart contracts. If you want to learn how to do blockchain development, this is the way. You start by looking at how other examples are done. And from that, you play around with it and you'll learn. You can go read the books, but sometimes going in a straight path is not going to be the best way to learn. Sometimes breaking it a little bit and understanding it is the best way. So do both. If you want, if you go on out to any, going out to Etherscan, you can pull up any token you want. LRC, Loopring coin, went up quite a bit this week. If you've been following some of the workshops I've done with the Guangzhou off-chain group, we took a Loopring back in March. And well, if you had bought in March, you'd be doing quite well today. This is an example of an ERC20, very similar to an ERC721, but it's a token, as we commonly call it. Again, tokens have smart contracts, and good tokens have their code published with it. So take a look at this. If you want, go look up some of the scam tokens. As a programmer, I love looking at scam tokens. I like to kind of poke around at them, say, how did that scam work? What did they do that made it, bad? And you can actually kind of see that. But using Etherscan is a great way of doing it. You can literally see what's in the smart contract, either by reading the contract, and you can even see what's the total supply, how many decimals they support, how many balances somebody have, what's the symbol, LRC. All this is available from tools like Etherscan. Use this tool, you'll learn a lot more about how smart contracts work. All right, we're gonna end it here at only 45 minutes. But if anybody in the room has questions about all the things we just covered or wants to go through more examples, I'm happy to go into more deep depth. So thanks again for everybody joining on in. I'm gonna start up the recording, but feel free to stick around and we'll answer some more questions.